So we'll go through the review today, and then the test will be on Monday. Then we'll start a new chapter on Tuesday. Okay, so the first question, name an angle bisector. Yep, an angle bisector means it's a ray or a line that bisects an angle. So we would be looking for markings that show an angle is being split into two equal parts. There's only one vertex that has those markings. That's vertex A, which means AD must be the angle bisector. Make sense? Okay. The perimeter of ABCD is 44. ABCD. So it's this shape here that I'm not going to be able to outline very well. The perimeter. So to find the perimeter of any polygon, you just add up the sides of the polygon. So I'm just going to add 2x minus 3 plus x plus 1 plus 2x minus 7 plus x plus 5 and set it equal to 44. And then it's just solving. So 2x, 3x, 5x, 6x. Negative 3 plus 1 is negative 2. Minus 7 is negative 9. Plus 5 is negative 4. Okay, so that was the first half, solve for x. The second half says, describe the relationship between AC and BD. Well, if I look at this triangle, I have two triangles really. This side's x plus 1. I said x was 8, so this side is 9. 2x minus 7, 16 minus 7, that's 9. Okay, 9. So that means that this triangle here is isosceles, right? Which means the distance from this point to the vertex is equal. And that happens if this number here, or this ray here, is a perpendicular bisector. When we learned about circumcenters in a triangle, it's made from perpendicular bisectors. These are all 90 at midpoints. That's the circumcenter. And once we know that these are perpendicular bisectors, the distance from the circumcenter to the vertices is equal. That's what we know about the circumcenter. So if I know that the distance from this point to the vertex is equal, I know that must be a perpendicular bisector. The inverse is also true, or the converse is also true. Okay, so the relationship between AC and BD, AC is a perpendicular bisector to BD. Okay, that was the second half. All right, point E is the centroid. BD, this whole length, is 12. EF is 7. AG is 15. So this is 15. This is 12. Hey, you two. You go in the other room, please. Thank you. They were distracting me, so I'm sure they were distracting you. Okay. BD is 12, AG is 15, and then EF is 7, this piece here. Okay, and it's a centroid. So with a centroid, the short side of the segment that's split is 1/3 of the whole length. The long side is 2/3 of the whole length, and the ratio between the two, the short to the long, is 1 to 2. Okay, so if I'm trying to find ED, ED is the short side of this whole thing. Well, the whole thing was 12. So we know the short side's 1/3 of 12, which is 4. Okay? That's the answer for this problem. But if we look, BE must be 8 then. And do you see how that ratio 4 to 8 is 1 to 2? Okay. All right. We're finding the centroid. I'll tell you right now, the test, you have to find the circumcenter. Okay, so if you need to review how to find the circumcenter, I would do that before Monday, because you're going to have to find the circumcenter on the test. Okay, but we're going to go through the process of finding the centroid here. I'm going to draw my axes here. So I have negative 2, 6. I have 4, 10. 4, 5, 6, 7, 8, 9, 10. And I have 14, 6. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Of course, we're just going to pretend. Is that right? It's not going to be exact because I ran out of room, but okay. We're going to find the centroid. So the first thing you're going to do is find the midpoint of two sides. Well, the midpoint of this side, I have a total of 16 units, so it's going to be at 6. 1, 2, 3, 4, 5, 6. Is that right? 14 minus 2 is 12. So, oh yeah, because my lines are, we'll just write this point as 6, 6. My scale factor's off, so just ignore the units. Okay, so the first thing I need to do is find the equation of this line. Okay, well, if this is 6, 6, the slope is 10 minus 6, which is 4. 4 minus 6 is negative 2. 4 over negative 2 is negative 2. So the slope is negative 2. Okay, I could go ahead from this point and use the slope of negative 2 and just use it up until I cross the y-axis. That shows me the y-intercept. Okay, so I'm going to go, here's the y-axis, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Count that. 2, 4, 6, 8, 10, 12. So it's going to be y equals negative 2x plus 12. If I didn't do that, I could have just plugged in one point and solved for what the y-intercept was, right? You can do it either way. So the equation of this first line, the first median, which is how centroids are made, is negative 2x plus 12. Let's find the midpoint between these two. 10 minus 6 is 4. 4 minus 14 is negative 10. So this one, wherever that midpoint is, that's the slope. That didn't help me. 4 plus 14 is 18, so this point's 9 and 8. Is that right? Yeah. And I know the slope, and I want to find the slope of this line. 8 minus 6 is 2. 9 minus negative 2 is 11, so the slope is 2 11ths. Now I find the equation of the line by plugging this point in. And solving for b. So I have what? 6 equals negative 4 11ths plus b. 66 equals negative 4 plus 11b. See, I just multiplied everything by 11 to get rid of the fraction. So 70 b is equal to 70 11ths. So that's a fun one. Whoops. Y equals negative 4 11ths x plus 70 11ths. So there's my second median. I just set this equation equal to this one and solve. For the sake of time, I'm just going to keep going, but that's the process. So for a circumcenter, because that's on the test on Monday, how do you create a circumcenter? It's not a median. That's a centroid. Perpendicular bisectors. Okay? So if I have a triangle and I'm trying to find the perpendicular bisector, I'll find the midpoint of two sides, right? And I'll find the line that goes through those two midpoints at a 90. Remember, it's not the altitudes. Altitude goes from a vertex. Perpendicular bisector just cuts through that midpoint at a 90. Doesn't connect to a vertex necessarily. Okay? And where those two lines intersect is my circumcenter. So to find this point, I find the midpoint, right? And then I use that midpoint, and I use the opposite reciprocal slope, because two lines that intersect at a 90 have the opposite reciprocal slope. So I'm going to use this midpoint and the opposite reciprocal slope of this line to find the slope of this one and write my equation. Do it twice, set those two equations equal to each other, and solve for x. Okay, that's what you'll need to do on Monday. Okay, let's get back to the rest of this now. If PO is an angle bisector of angle MON, what do I do to those two expressions? What does an angle bisector mean? Okay, so the two angles are equal. These two angles that are created by the bisector are equal. So I just set 2x minus 10 equal, and then solve. That's it. Okay. This next one has to do with inequalities, triangle inequality theorem. So first I can figure out this angle is 15, and I know this angle then must be 95. So the biggest angle in the triangle is is 95. So the side opposite the biggest angle must be greater than the side opposite the smallest. Right? And it wants me to do it relating x and z, so I'm going to say x over 5 must be less than 2z plus 3. Right? Okay, and then just solve for x. X must be less than 10z plus 30. So when I distribute the 2, I get 6. 6 times 5 is 30. So that's the relationship between x and z. That's it. Everybody follow that? Okay. Next one, list the angles in order. Okay, so the smallest is going to be opposite the 1.2, so that's angle I. And that's going to be less than the angle opposite the 2, which is h. And then finally, g. List the sides from shortest to longest. Shortest side will be opposite the 45. Then next would be opposite the 55. And then next would be opposite the 80. Okay. Find the shortest segment. Well, I need to figure out what this is in relation to this triangle. This is the largest segment of this triangle. Does everybody see that? Because it's opposite the 65. So it's bigger than both of these. Right? But it happens to be the smallest on this side. So the biggest side, or the shortest side, that's what I'm trying to find is the shortest side. This is the shortest of this triangle, but the longest of this one. So this right here, xy, must be the shortest of that whole thing. Just logic through it. Does that make sense? I mean, go through that logic again. Everybody got it? Here, go through it again. So what I did is I looked at YW, and it's opposite the biggest angle in the left triangle, which is 65 degrees, right? So it's the biggest side in this triangle, but it's the smallest side in this one, because it's opposite the 55 degrees. And I'm trying to find the shortest or the smallest, the shortest segment. Okay, so the shortest segment in this triangle is that side, YW. But that's the longest segment in this one. So the shortest segment in this triangle is definitely going to be shorter than this one. You see what I mean? So the shortest segment of this whole thing must be the shortest segment in this triangle, which is XY. Okay. This one, I don't remember if this was on. Was that on the review? Okay. I've got an old review up, so we didn't go through that. And I didn't do this one either. And this one. Okay. Number 13. The measures of two sides of a triangle are 10 meters and 23 meters. If the measure of the third side is x meters, find the range of the value of x. So remember, when we're trying to figure out possible third sides, okay, one possibility is that third side is the shortest of this triangle. Okay, so I'm going to draw 23, 10. Well, let's just do this. 23. Let's make this 10. That's the shortest side of this triangle, right? Everybody see? Okay. Then I'm going to make another triangle where x is the longest side. So this is x, this is 10, this is 23. Okay, those are the two possibilities that x could be. It could be the shortest side of a triangle, or it could be the longest side of the triangle. Everybody with me so far? Okay, if it's the shortest side, this side plus this side must be greater than this one. The two short sides must be greater than the longest. That's the triangle, I don't remember what it's called, which theorem it is. But the two sides have to be greater than the third. So I would say x plus 10 has to be greater than 23. And here, the two short sides are 10 and 23. 10 plus 23 has to be greater than the long side, which is what we don't know. Right? Now I'm just going to solve for x. X has to be greater than 13, or x has to be less than 33. See how 33 would be greater than x? So x would be less than 33. So it's between 13 and 33. It can be anywhere in that range, and it would still work. It would still make the third side of a triangle. Okay? If it's on the short side, it has to be greater than 13. If it's on the long side, it has to be less than 33. Okay. Number 14. PU is a median of PTQ. PTQ. So I know this is equal to that because it's a median. Right? If UQ is 6, find TQ. So there's TQ. UQ is 6. Well, this has to be 6 also, so TQ must be 12. Right? Okay. That's it. All right, number 15. If BD bisects ABC, so this is an angle bisector, find the value of x. Well, if it's an angle bisector, we know from when we learned how to do incenters, angle bisector. Once you know the angle bisector, that point on the angle bisector is equal to both sides of the triangle, or in this case, both sides of the angle. So I would just set 2x plus 30 equal to 3x minus 4. So negative x equals negative 34. X is 34. Write an inequality to compare EF and GH. EF and GH. Well, EF is opposite a 20-degree angle, and GH is opposite a 23-degree angle. So EF must be less than GH. And then an inequality to compare angle 1 and 2. Well, angle 1 is opposite 12, and angle 2 is opposite 11. So angle 2 is less than angle 1. And that is it. Okay, I will still let you use your sheets. Okay. I would review how to find circumcenter of a triangle if you're given 3 points, because you'll have a problem like that on the test. And then maybe what's the hardest part after that for everyone? Triangle inequality theorem. Are you understanding that? Okay.
You need to know circumcenter? Is that what you said?
Yeah, you need to know how to find the circumcenter for the test.
That's just a perpendicular bisector.
Perpendicular bisectors, where they intersect. Yep, so find the equations for 2 perpendicular bisectors, set them equal to each other, solve for x, plug x back into one of them, solve for y. Okay, and don't forget, if you have not finished your worksheet, I will still accept them for an extra bonus point on the quiz. Yes. Yes.